All right. Hey, we're going to go ahead and do 1.2, parent functions and transformations. Now, if you haven't already watched the video on transformations, transforming functions, you should really do that because I'm not going to really go into the transformation piece today, but I am going to talk about the parent functions. Okay, so the different parent functions that we need to worry about. This book actually talks about the constant function as f of x equals 1. Now, I had never heard that until I started using the current textbook that I'm using, but I knew a constant function, but they say the parent function is actually f of x equals 1. So that's the function. The actual graph of that would just be a horizontal line going through the y-axis at 1, or the f of x axis at 1. Okay? I'm going to talk about domain and range at the end here. But linear, f of x equals x. So if you think back to algebra, linear was y equals mx plus b. So if we get rid of the b and we just say our y-intercept is 0, and we have a slope of 1, that is our parent function. Okay? And so if we kind of zip through here, 1, 1, 2, 2, 3, 3, and so on. All right, that is the graph of our parent function for the linear equation. And then absolute value, f of x equals the absolute value of x. Okay, and absolute value, if we plug values in here, put 0 in for x as an input, we get 0 out as f of x. We put 1 in, we get 1 out. We put 2 in, we get 2 out. Now if you recall, an absolute value graph back from algebra forms a V shape. And so no matter what value I put in terms of the positive, I'm going to get the same positive value out. That changes when I put in a negative. I put in a negative value, I don't get a negative out, I get a positive. Okay? And so I put -1 in, the absolute value of -1. Remember, absolute value is distance from 0. So the -1 is 1 unit away from 0. So I get 1 out. I put 2 in, absolute value of I put -2 in. The absolute value of -2 is 2, and so on. So I keep hitting the side piece here, sorry about that. All right, so -1, 1, -2, 2, -3, 3, -4, 4, all the way up. So I kind of have that check mark there. I missed the line there. Do that again. That's a little there. Okay? That's my absolute value function. And then quadratic is f of x equals x squared. And so, once again, if we did just I'm going to do a quick input-output table here for those of you who've forgotten those. That's x, my rule is x squared, and my output is y. So my input x, my rule, my output. So if I input 0, I get 0 squared, and 0 squared is 0. Okay? And so I'd have the ordered pair 0, 0. If I input 1, I'd have 1 squared for x, and then my output would be 1. If I input 2, I'd have 2 squared for x. My output would be 4. Okay? And that is not 4. So let's fix that real quick. No, that does not want to erase either. Oh, interesting. Alright, so I'm just going to cross out that point, which is not a good route to go, but I'm going to put input of 2, output of 4. And in fact, if I input 3, I'm going to get an output of 9. Okay, and input -1. -1 squared is 1. Input -2. -2 squared is 4. So a negative times a negative is positive. And what you see, if you recall, this is just a reflection over the axis of symmetry. But you'd have a parabola, okay, and it would look something like that. Those are our parent functions. Now, the domain and range, domain stands for your x values, range stands for your y values. Okay? And so when I'm dealing with domain and range, one way to think about it, D comes before R and X comes before Y, so domain and range. Now, this is saying where do your X values exist for this graph? Well, if you look at it, X exists at 1, 2, 3, 4, 5, and it keeps going on forever. No matter what I put in for X, I still get an output of 1. So X is equal to all real numbers. That means any real number I put in, real numbers are the numbers that we're familiar with, they're not imaginary numbers, will give me an output. Now notice, really there's nowhere to put anything in. It's just your output is always 1 here. Another way of writing all real numbers is doing that right there. All real numbers. Now my range says, where does it exist for Y? When I start looking at this, well, it only exists right here for Y. If I go up here, my graph doesn't exist exist at 10, at 9, at 8, 7, doesn't exist at -10, -9, -8. It only exists on 1. So my range is just Y equals 1. Okay? In terms of linear, well, I'm going to just extend this over. In terms of linear, my domain, so again, I can put any value in for X. No matter what I put in, I'll get an output. Okay, so if I put 100 in, I'm going to get 100 out. Okay, so X is equal to, once again, all real numbers. And you can kind of see that. The graph extends in both directions forever. Okay, down here for Y, notice my graph is extending upward forever as well, and downward forever. So that's also all real numbers. In absolute value, X, well, X starts here at 0 and goes this way forever. So it's going out this way forever and going this way forever. So X is also equal, once again, to all real numbers here. Now in terms of Y, notice it starts here at 0 and it only goes upward. It doesn't go downward. So at 0, you have a Y value of 0. Your output is 0 when X is 0. Your output is 1 when X is 1 and -1. Your output is 2 when X is, or your output is 2 when X is 2 and -2. Your output is -1, never. And your output is -2, never. So your outputs only exist when Y is bigger than 0. And it actually can be 0 as well. So we have to say greater than or equal to. Y has to be greater than or equal to. And you can kind of see that on your graph. It starts here and goes upward. Okay? So my graph is going upward. Therefore, that is my my range there. So it only exists up here for Y. It doesn't exist down here. Whereas in these graphs, it existed everywhere for Y, above and below. On this graph it did. On this graph, it only existed right here for Y, at 1. Okay? Well, if you look at this graph over here, same thing happens. For my range, it only exists when Y is bigger than or equal to 0. It doesn't exist down here. Okay? For X, it keeps extending outward forever. This graph gradually grows upward and outward. Okay? So in terms of my domain, X is, once again, all real numbers. Whereas my range, Y has to be greater than or equal to 0 again. Now if this was opening downward, it would be Y is less than or equal to 0 because it would have to be lesser than 0. Okay? It gives you a little about parent functions and domain and range.